Chess is a sport that has been around since the 6th century, and like many sports, math is integral to it. Starting with the board, it is an 8 by 8 board with a total of 64 squares. Along with 16 pieces for both sides, that leaves endless possibilities in what could happen within a single game. While many times people say endless in terms of hyperbole, for example, let me put this in perspective, there are 10 to the 81st atoms within the universe. And that doesn't even come close to the amount of combinations that can occur on a single chessboard. So let's get into how chess can be useful for vertex covers. A vertex cover is a set of vertices that includes one endpoint at the edge of every graph. Well, finding a minimum vertex cover is a popular optimization problem within the world of computer science. This problem is known as an NP-hard or non-deterministic polynomial time hardness optimization problem. So some of the properties of a vertex cover goes as follows. A set of vertices is a vertex cover if its complement is an independent set. The number of vertices of a graph is equal to the number of minimum vertex cover plus the maximum independent set. So, how does this apply to chess is really the question. And the most important way to do this is that we can create domination problems, which are essentially just vertex cover problems, but on top of a chessboard. This will help many people in the world of computer science visualize a vertex cover problem on maybe something physical or just something they're more used to, which can help further their education, further their help in becoming better programmers. So we'll start with an easy one where we'll have a rook. It can move forward, backwards, side to side. And all we need is for to have enough rooks, the minimum number of rooks to cover the entirety of the board. So I am talking from here to here, here to here, here to here, and here to here, and everything in between. Just the minimum number of rooks. I'll give you some time to solve this. Well, if you guessed 8, you'd be more than correct. So in this problem, it doesn't matter if the rooks are attacking one another, because we are just trying to see how they could just cover each of the square. Whether they attack each other or not is regardless of this question, or it does not matter within this question. While rooks are the bare basic of the domination problem, with other pieces like kings and knights, the domination problem can become a lot more complex, and I would really, really encourage you to venture out and go check them out for yourself. Thank you. And if you guessed 9, I'm actually kind of impressed. Yeah, you nailed it. Um, it's very simple. Once you find out the pattern of, okay, the king covers here, 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 covers all these squares around, then all you have to do is just repeat that over and over and over again, and eventually the entire board will be covered by the kings. Now there's one more way domination problems are set up, and they can also be set up where you have to cover every part of the board, every single square, including the ones that, like, you also have to, including the ones that are occupied. So for example, the set we just had with the 9 kings, that wouldn't work because all the kings weren't under attack. So I will give you one more chance with the knights, who we are familiar with move in this jumping frog formation, we'll say. So I'll just give you some time to figure out how will the knights cover every single square on the board, including the ones that are occupied. If you guessed 14 knights in a formation similar to this, or this exact formation, you would be very correct. And you are more likely a better chess player than I am. So this really is more meant to represent how chess is still practical in modern day math, and that we can still innovate and show that, like, modern day math theories and modern day math problems in a way where we can incorporate chess and make it easier for people to understand whom, let's say, are chess players. As there are studies that do show that chess players tend to be better at math because of the problem solving skills. Like I showed earlier with the puzzles, and there's other chess puzzles. There's positional puzzles within chess. There's other types of puzzles where you calculate all different types of lines. There's even studies that show that IQ scores have increased as players have played chess. And that's why I think we need to further push chess and have kids know it exists, have kids know it's actually fun, have kids know there are different ways to do it, and have teachers know that chess is a practical use of their time and that it can be applied to math, and it's not just some silly game, it's not just some old game, and it's something that can still be improved upon and used better within the math scene. Thank you.